So we are going to go ahead and review how to graph systems of equations and kind of talk about what it means for something to be a solution of a system of inequalities rather than a system of equations, because it is slightly different. So I'm going to start just by graphing our first inequality here, because that's already in slope-intercept form, so it's really easy to do that. So we're just going to go up 1, 2, 3, 2, 3 right there, and then the nice thing is it's all really easy to see the graph, or it's all really easy to see from here what the slope is, which is 3/4. So we're just going to go up 1, or we're going to go up 1, 2, 3, 4, which gets us at about 7, and then we are going to go over. Wow, made a classic mistake here. I mixed up the rise over the run. So remember, it is delta y over delta x, so we're actually only going to go up 3/4. So we're going to go up 1, 2, 3, lands us right at 6. You don't need to put a point there, but I just did so you can see a little bit more clearly. And then we're going to go over 4. So we go over 1, 2, 3, 4, which lands us right about here. And as we can see from this inequality, it is less than, strictly less than. So y is strictly less than 3/4, and that just made it look like a less than or equal to sign, so I'm going to erase that. But it is strictly less than, which means that we're going to connect those dots with a dashed line to show that the points along this line, not part of the solution. Okay? So make sure you keep that in mind as you are graphing these, that when the points are dashed, that means that these points right here along this line are not part of the solution. Okay, so I'm going to go ahead and now graph the second equation. I'm going to graph it in green so we can clearly see the distinction. So I'm going to go down 1 to -1 for our y-intercept, and then our slope is 2, or -2, so we're going to go down 1, 2, over 1, or 1, so right about here. So that means we're going to draw a solid line because it is less than or equal to, in this case. Okay. So ordinarily, we would say that this point of intersection right here, whatever it may be, is our solution to the system of equations. The only thing is, with this, it's a little bit different because the solution to this system of equations is not just this singular point. And on this line, it's not even included with this point because this is a dashed line. So whatever is on this line is not included. Instead, we have to find all of the points where y is less than 2, or less than -2 minus 1. So since it's less than, it means it's going to be going this way. So we're going to shade for this side all of the points here. And we can check that with the point. I'm going to use the y-intercept. We're going to use, actually the y-intercept is pretty obviously on the line. I'm going to use, we'll check this one with the point 0, or -4, 0. So we have y is equal to 0, x is equal to -4 minus 1. So we get 0 is less than 2. Clearly we can see that this is going to be greater than 0. So this means that this point right here is part of the solution, so we are correct in how we've graphed it. This is not something you have to do. It's just something that helps me. So this inequality is true, so you can see that we're good to go there. And it's going to be the same thing with y is less than 3/4 x plus 3. We're going to shade below the line because that helps us see where the lines, or what parts of the line are included. So it's all points that are below this line, that are less, where y is less than 3/4 x plus 3. The solution to the system of these inequalities, so this is a system, is all of the points that are below these two lines. So that would be all of these right here where the solutions overlap. So for these two, it's in this section right here where all of these systems of inequalities, or where all of the solutions for the system of inequalities overlap. So what that means is you can choose a point from inside of this section and it will make both of these inequalities true. It will satisfy that system. So that is just all right. So we're now going to look at another system of inequalities and figure out what these solutions are. So as we can see, this one right here is not completely in slope-intercept form, so we cannot actually see what the slope and the y-intercept are. So let's go ahead and start by putting this guy into slope-intercept form. My pen is running out, so I'm actually going to switch to a different color. So we're going to start by, we actually only have one step that we need to do. All we need to do is divide both sides by 2 to get the y completely alone. So 2y divided by 2 just leaves us with y. No positive or no negatives, so we're left with y is less than 4x divided by 2, which gives us 2x. Negative 6 divided by 2, which gives us negative 3. So we have this line completely in slope-intercept form, so let's go ahead and graph it. So we're going to start by going down 1, 2, 3 to find our y-intercept, which is negative 3. And then we're going to go up 1, 2 over 1. So we wind up with a point right there. And we can just draw, 1 second there. We have to draw a dashed line because this is a strictly less than. And to show that it is all the points less than, or where y is less than 2x minus 3, we're going to shade this half in, because it is less than. All right. Now we're going to move on to this second equation. Our y-intercept is 1, so we're going to start at 1, and then we're going to go up 1 over 1, 2, and then draw our point right, or draw our line through those 2 points. Intersect right about there. And then this is also less than. Y is less than or equal to 1/2 x plus 1. So we're in a little bit of a unique situation here because this guy kind of envelopes the other. So the solution of both of them is not included right here, but it's actually, it starts right where the 2 lines meet. So it starts here and then continues on through, I'm going to shade that in a different color. So it starts here and then continues on where the lines meet, which is right here and beyond. So it would keep going.